you, my friends? Here I'm continuing basic math terms, part 7, about radicals. So there are 12 words I need to explain about radicals. Please, if you need to see the other videos on basic math terms, you can go to the playlist called Basic Math Terms. Many parts are there. Now, this is part 7. We need to see the difference between radical, radicand. You see the second word here, radicand, the index, even index, odd index, etc. We have distributive properties. We have rationalize, number 11 here. Rationalize, we have denominator. Sometimes also we have numerator. Now let's see. The radical. This is a radical symbol, and that's positive always. You can see that in other videos. This is only to explain the word. Radical means this symbol, it's always positive. So the square root of A is equal to B. That means B squared is A. So the answer here is positive. Like square root of 9 is 3, not minus 3, not plus or minus 3, only 3. Now the index, look at the word here, the index. This is the small number in the radical. This is the index. The number under, see the A, we call it radicand. So the number under the radical, inside, is called radicand. And we call this nth root of A. Nth root of A is equal to B. That means B to the power n is equal to A. If n is even, remember, we have even and odd, even number divisible by 2. If n is even, A should be positive and B should be positive. Rational exponents. See, in the power here, we have 1 over n. In the power here, we have fraction. In the power, rational means we have a fraction number here. So that's also radical. A to the power 1 over n, nth root of A. Like A to the power half, square root of A. A to the power m over n, this is also radical. The number in the denominator here is the index. So nth root of A to the power m. Also this power m, you can leave it outside or you can leave it inside. This is a simple example here. You can read 64 to the power 2 over 3. So if you need the simple answer, it's 16. I put one method here by using this formula, or another method by using the power here. 64 is 4 cubed times 2 over 3, multiply the power. If you know the properties in the two powers, you multiply the power. So the answer is 16. Now, when you evaluate radicals, find the value of a radical, you should have the number of A's here, A to the power n, the same as the index. Then you can simplify it. But before you write the answer, you check, is the index even here? The index is even or odd? Even like 2, 4, 6, 8, 10, etc. Divisible by 2. The odd number is 3, 5, 7, 9, etc. It's not divisible by 2. So if it is odd index, the answer is A. If it is even, the answer should be absolute value of A, which means positive. Look at this example here. If someone asks you, is this correct? Square root of x squared, is that correct? No, if the answer is x here, it's wrong. The answer should be absolute value of the x. Why? The index here, see the index hidden, it's even. Another reason I can give you, if x is equal minus 5, let's put x here minus 5 inside. Minus 5 inside all squared is 25. Now what is the square root of 25? We know it is 5. And 5 is not equal to x because x is minus 5 given. So again, the whole summary says, if the index is even, write absolute value. Now we have some rules in the radicals. The most important three, the first one is the product, but you should have the same index, remember here, same index. Quotient, you divide, you should have the same index. And then two radicals, when you have mth root of nth root, multiply the indices. See, each one we call it index. M is index, n is index. When you multiply the plural, it becomes indices, mnth root of a. But remember, there should be no number in the middle here. Only two radicals, multiply the indices. Okay, like radicals. When do we say like radicals? Radicals are like. Like means the same index, same radicand. That's the definition. See here, 7 square root of 3, 4 square root of 3. You see that? Same index, 2, 2. The index is 2. Same radicand, 3, 3. Then we call them like. Like and is similar. That means we can add them, we can subtract them. Unlike, you see here, square root of 2, square root of 3. The index is same, but the radicand not the same, so we cannot add here. Okay, so adding and subtracting radicals, we can add like terms, we can subtract like terms. So this one, 8 square root of 3 is 6 square root of 3. Take the square root of 3 common, you can add 8 plus x, so that's 14. Or this is the same like if I say add 8y plus 6y, just write on your paper, 8y plus 6y, what is the answer? You should tell me 14y. That's the same. Now here we cannot add because 11 and 10 is not the same number here. We cannot add, we cannot subtract, leave it. This one we can add. 3 minus 7 because we have the same index, same radicand. Rationalizing, you have to understand the word rationalize. See the word rationalize, big word here. Rationalize is the verb. Rationalize means remove radical. See, they all start with R. Rationalize means remove or get rid or take out or take away or cancel or delete or leave it without radicals. So rationalize means remove the radical. If we say rationalize the denominator, then we have to remove the denominator, the radical from the denominator. If we say rationalize the numerator, later you can see questions. When you look at the lectures, there is algebra course lectures in details. You can check the playlist, please. Algebra course lectures. You can see there in details. Sometimes we say rationalize the denominator. That means remove the radical from denominators. Sometimes we say rationalize the numerator. Remove the radical from the numerator. Now here, easy, I just put one example here or two. Square root of 3, multiply up and down by the same number. This is like 1, because you cannot, in math, you cannot change the question. You cannot multiply square root of 3 down. You have to multiply up and down always. If you multiply by 5, up and down. If you multiply by minus 2, up and down. If you multiply by square root of 3, up and down. So this becomes 4 square root of 3 over 3. Now we finish because we removed the radicals. This is more difficult, please, but I can explain it very quickly. 7th root, 1 over a squared. So by using the properties here, 1 over 7th root of a squared. Now, the important thing in number 2 is to look at the index. Can you tell me, please, what is the index in number 2? Well, you should say 7. 7 is the index. See, like you need 7x. You have only 2 of them. See, x, a squared. It can be x squared or something. You have 2 of the 7. What's left? 5. So I write here a power 5. Same index, square root of 7th root of a power 5. Because when I multiply down a squared, a power 5, I add the power, it's a power 7. So this is a now, finished. You see? So look at the index, see how much you have from the index, multiply by what's left. 7 minus 2 will be 5. Okay. Now there's a simple 3 questions I think here. Simple questions just to understand the idea. And then there are 2 practice questions you can try yourself. The answers will be provided the last slide. Find the value of this. See, this one is similar. I will show you, go back, go back, go back, go back. Similar to this one here. You see 64 to the power 2 over 3. So I give you one question there similar to this. Here you have 2 methods. And there is one in the negative power. This is negative power, this is positive power. But both are fractions, rational numbers. Let's see. 4 to the power minus 3 over 2 divided by this. Let's simplify this. Let's simplify this. When you finish, divide the numbers. It's not that difficult. And then you should get one answer, one simple fraction or one number. So the fraction you should get in the answer, final answer, 1 over 72. Let's see how. 4 to the power minus 3 over 2. So I can write 4 power half, all to the power minus 3. See, 4 power half, this is easy number. Square root of 4, which is 2. 2 to the power minus 3, 1 over 2 cubed, 1 over 8. Leave it. So the first number is 1 over 8. Now let's take the second number. 27 to the power 2 over 3. I can use the radicals. This is cube root of 27 squared. 27, I know 3 power 3. See, 3 power 3 power 2, I can switch the powers. 3 squared all cubed. Because cubed, I have the index 3. So there are 3 9s, 9, 9, 9 inside. So the answer is 9. 1 over 8 divided by 9, 9 over 1. Remember, we have seen these fractions. When you divide 2 fractions, 1 over 8, you change this division into multiplication and you multiply by the reciprocal 1 over 9. So 1 over 72 is the nice answer. Let's see question number 2. Simplify 6th root of x to the power minus 6 divided by 5th root of 32 if x is greater than 0. So we know x is positive number. To make it easy, I gave you this condition. You can pause the video a little here, maybe a few seconds, and then check the answer. We can see together the answer will be 1 over 2x. Because this one I can change it to rational exponent, x minus 6 divided by the index 6, and 32 is 2 power 5, which is 2. This is x to the power minus 1, 1 over x. So the final answer, 1 over 2x. Now let's see here, rationalize please. Not easy question, but you can do it. Rationalize the denominator here. 5 over 2 minus square root of 3. We need to remove the square root of 3. We need to leave the answer with a number or fraction or something that has no radicals. So I multiply by the conjugate here. 2 plus square root of 3. See, multiply by conjugate 2 plus square root of 3, 2 plus square root of 3. Why? Because when I multiply down, there is a formula, we call it difference between 2 squares. So you multiply this here, 2 and 2. 2 times 2 is 4. Square root of 3, square root of 3, square root of 3. There is a minus in the middle. So 4 minus 3 is 1. So that's 1 only. See that? You can have 2, you can have 5, you can have 7, you can have 8. It's not always 1. It can be any number there. Now here, 5 times this, just distribute. 5 times 2 is 10, minus 5 square root of 3. That's the answer. See now this one here, no radicals in the denominators. Now this is practice number 1. Simplify the answer. You know, you can use the formula here for perfect squared, or you can multiply this times this in 2 brackets, then distribute square root of 3, give me the answer. And here, evaluate this expression. It will be one number there. The answers in the last slide here, these only the answers for practice 1 and 2. Thank you for watching. I hope I can see you in another video with another topic. Thank you very much.